Problem number 13. Lucy, mass 33.1 kilogram. Henry, mass 63.7 kilogram. And Mary, mass 24.3 kilogram, sit on a lightweight seesaw at evenly spaced 2.74 meter intervals in the order in which they are listed. Henry is between Lucy and Mary, so that the seesaw balances. Who exerts the most torque in terms of magnitude on the seesaw? Ignore the mass of the seesaw. Solution. In this problem, we don't even need to calculate anything, because let's say we have a point of balance exactly in point of Henry. It means that Lucy will create a greater torque than Mary, and there will be no balance. Seesaw will go counterclockwise if Lucy at the left and Mary at the right. So now we need to move this point of balance a little bit to the left from Henry. And in this position, when we find this point, it means that Lucy creates the same torque as Henry and Mary together. It means that Lucy creates a greater torque than anybody of Henry or Mary. So that's the solution. B is correct answer. Problem number 14. A wooden block of mass M is hung from a peg by a massless rope. A speeding bullet with mass small m and initial speed v0 collides with the block at the time t equals 0 and embeds in it. Let S be the system consisting of the block and bullet. Which quantities are conserved between time negative 10 seconds and time positive 10 seconds? Solution. Let's investigate all 5 possibilities. A. The total linear momentum of system. Before collision it's conserved, but after collision, when this system starts to rotate around this peg, there is a force acting on this peg and bullet, which is changing total linear momentum and horizontal momentum. So it means that not A, not B are good answers. C. The mechanical energy. Mechanical energy is not conserved because here we have absolutely inelastic collision and we will lose some energy during this collision. D. The angular momentum of a system as measured about a perpendicular axis through the peg. It's conserved before collision, but after collision, when this system starts to rotate counterclockwise, we have gravity force which acting clockwise, so it's changing angular momentum, and D is not correct answer. And answer E, none of the above are conserved, which is true. So correct answer is E. Problem number 14. A 22 kilogram suitcase is dragged in a straight line at a constant speed 1.1 meters per second across a level airport floor by student on the way to the 40th IPHO in Merida, Mexico. The individual pulls with a force F equal 100 newtons along a handle with makes an upward angle of 30 degrees with respect to the horizontal. What is the coefficient of kinetic friction between the suitcase and the floor? Solution. First, let's draw the free body diagram. Because this suitcase moving with a constant speed, it means that this is the situation of equilibrium. So we have to write horizontal and vertical equations for equilibrium. Let's do this. So first we have horizontal force F acting at angle phi equal 30 degrees, and we have force of friction acting opposite side. So this is the equation. We have force of friction equalize force F, pulling force F multiplied by cosine phi. Second equation, that's vertical. We have force of gravity mg, which equalized by normal force and vertical part of pulling force. So that will be this equation. mg equal F sine phi plus normal force n. Next one is relation between normal force and force of friction. Because this body is moving, it means that we have this equation, that force of friction equal coefficient of friction multiplied by normal force. Now let's exclude some components. So first we can take normal force from this equation and insert it here. So we have force of friction equal coefficient of friction mu multiplied by mg minus F multiplied by sine phi. And now we can insert this expression for force of friction in this equation. And after that we can express a coefficient of friction from this last equation. So we have this expression, that coefficient of friction equal force F multiplied by cosine phi and divided by mg minus F sine phi. The last step is to put all numbers, and after that we can count that this coefficient approximately equal 0.51, which is close to answer C. So C is correct answer.